All right, so this is 7.3. We're going to specifically focus on method 2 of graphing and talk about standard form, how to find intercepts, and axis of symmetry. So just some refresher. So 7.3 is solving quadratic equations by graphing. So yesterday, it's a brief reminder. Those of you that weren't here, hope you watched the full video. This is a brief reminder on method 1. If you're given equation 1 like this, a parabola, let's say, and equation 2, something looks like this, like a straight line, you can find the intersection points of those two graphs using the graphing calculator. And so the intersection points would be this point right here and this point right here. There would be two times, time 1 and time 2, where the y value is 72. Okay, so there would be 2 times where the y value for this first equation is 72. And this might be for a problem like if a projectile or something is launched into the air. The question might be, at what times is the object exactly 72 meters above the ground? And you would be able to track its path by this equation. And then if you let the second equation equal to the horizontal line of y equals 72, you can find out what time the projectile, hits it on the way up with this, and then what time it hits it on the way down. And those would be the 2 times after the launch time of t equals 0. So how we did that was, first method was to graph both equations. So the left side and the right side of the equation here, or graph both of these equations separately on your graphing calculator, and then find the intersection point. So let's see if I still have these up. Okay, I do, but this was for a second question. So there's your equation right there. All right, make sure you use this button, the negative button, for a negative sign at the beginning of a math statement there, and this minus button, that's for if you have something, a minus in between 2 terms. Okay, so the calculator needs you to differentiate those two. So this is a negative 4.9x squared. There's no t that'll show up here. It just always shows up the variable as an x. So it's this button right here. You put in 2 of them, and then you graph. You may have to adjust your window, which we did here. We adjusted the x maximum and the y maximum, and we can see 2 intersection points. Again, real quickly, to find the intersection points, it's second function, trace. That'll get you to the calculate menu. You scroll down and you go, I want to go to 5 intersect to find the intersection points. It'll pop to this screen where the cursor will be on one of the graphs. It'll ask you first curve question mark. You hit enter to say yes. And then it'll pop to the second curve, question mark, you hit enter to say yes. And then it'll ask for a guess, and at this point, before you hit enter, you have to move the cursor to whichever intersection point you want it to calculate exactly. Because there's 2, it'll just pick 1. So if I wanted to pick this one, I hit enter one more time, and there's my 12.722 is one of my answers. Okay, so that's this one, 12.722. And then you do that again for the other intersection point, and you should get 1.15. Okay, that's method 1. 2 separate equations, intersection point. Method 2 is very similar, okay, and this may be appropriate in certain situations, but you can, in method 2 now, rearrange the equation to equal 0. And then you just graph one equation and find the roots or the zeros of that quadratic function, which turns out to be the x-intercepts. So I'm gonna jot down the same. We're gonna do the same one. I want you to do this as well in your graphing technology that you may have. So I'm gonna go to y equals. So it's negative 4.9. So I have negative 4.9 t squared. This should be a t. T squared plus, was it 68t? Okay. And then I have equals 72, right? So let's say this is our original question. You can graph the 2 equations like method 1, y equals this one, and then y equals this one. That's method 1. Find the intersection point. Or you can do this. You can actually bring the 72 over to the other side and make one equation, which would look like this, negative 4.9 t squared plus 68t minus 72 equals 0. Okay, if you do this, then you can just graph one equation. So this is now a situation where I have a function and it equals 0. So I want to find the value or values for t that makes this function, this equation, equal 0, which are the intercepts of the graph. So if I graph this one, y equals negative 4.9 t squared plus 68t minus 72, then I'm looking for, I want to determine the x-intercepts. Okay? Not the y-intercept, but the x-intercepts. And that's our equation, that's the solution to the equation. Okay? And in this case, it would be the t-intercepts, I guess, but the horizontal intercepts, right? Because it's t. And that's the x-intercepts. All right, so let's do that on our calculator. So I am going to get rid of this equation here. So right now I'm going to just clear that. You can just clear the equations. And then I'm going to go back up here, and you might have this already programmed on your calculator from yesterday. This is where we do the minus 72, not the negative 72. The calculator won't like that. It has to be minus. So negative 4.9, and you hit your variable button, x squared, plus 68, variable button, x, minus 72. Okay? So I'm going to graph that. I'm going to use the same window as yesterday. This looks very much the same, doesn't it? But what happened here was that we moved our original parabola down 72 units so that this horizontal line that was 72 before is now 0. See, we just took the whole parabola and we moved it down 72 units so that this horizontal line is now the x-axis. So let me just show you something. You don't have to do this, but let me just show you something. I'm going to type this in again, negative 4.9 t squared plus 68, and I'm going to type the 72 in here again. So watch what happens when I graph this from before. Oh wait, what? What did I do? Oh, plus 68. Okay, I missed the x there. Sorry. X. Too busy talking. Okay, so that's the one we just did here. This is the old one from yesterday. You see? So what I did was I just, instead of having two equations, I combined them to make this one parabola down here. And this line moved down to the x-axis. So that when I combine them, I just need to find the intercepts. Okay, so now I'm going to get rid of these two again, clear, clear. And I'm going to find the intercepts for my parabola. Now how we do that is very similar to finding the intersection point. Hit second function, trace. That'll get you to the calculate menu again. Now notice that we're not going to use intersect. Instead, we're going to use this number 2 function, 0. So I want to find the zeros or the roots of the function. So I'm going to hit number 2. Now, it gets a little bit goofy here, I would say. So watch this. What you have to do now, and actually it would be easier for me to draw this before I do it on here. What you have to do is, if you're looking for intercepts, you have to tell the calculator, okay, I want you to find this intercept, but what you have to do is you have to give it a boundary. You have to give it a left boundary, and so you have to move the cursor kind of to somewhere to the left of the intercept or below it, and it'll say left boundary, and you would click enter to set the left boundary. Then you would move your cursor back up or over to the right, somewhere above or to the right of the intercept, and set your right boundary. Okay, that's how it works for intercepts. Then you're asking the calculator to focus in between these two boundaries where there might be an intercept. Okay, so it's, I don't know if it's a little more work or less work. It might be a little more work, but let's do it. So the left boundary, okay. So I'm actually going to change my window setting just a little bit so I can see the lower part of this graph a bit better. So my y min, and you can certainly do this too, hit window. Let's go y min to negative 20 maybe. Okay, y min to negative 20. And that, I don't know if that helps. I guess I didn't move it up maybe quite enough. Let's do it again. Let's go to window, and let's, y max is 350, so let's make this negative 100 maybe. Okay. So all we're looking for is the intercept, so let's move that up a bit. Okay, so now I'm going to do second function, trace, which is my calculate menu, go to 0. And let's focus on this intercept then. Right now, this is a fine left boundary, so I'm just going to hit enter. And do you see how it puts this little arrow there? That's this. I'm setting the left boundary. Now, let's cursor right until it drops below the x-axis. And then it's asking for the right boundary. I'm going to hit enter and set the right boundary. Do you see that? So now I'm going to tell the calculator to look for the 0 in between these two left and right boundaries. I'm going to hit enter. And boom, it should pop right onto the x-axis, the intercept point. And notice that this is 12.722. Okay, so this is 12.722. This is one of the same answers that we got yesterday. 12.722, you see that? So we're really finding the same things here. So that was this one that we just did, right? Set the boundary, find this intercept. So let's do the same thing for the other one. Whoops. So I'm going to go second function trace, number 2. And now I'm going to move my cursor over. And there actually is a shortcut. If moving the cursor over takes way too long, you could just type in a value that would be to the left. And I know that 0 is to the left. So you could just set the boundary to a number as well. And it'll just go ahead and do that. And then I could pick another number here or move my cursor. So if I move the cursor over, you get it so that it's to the right of, or you could just choose a number like 5. And I know that that is between 0 and 12. This is 12 over here, right? So now I've set my boundaries, and then I'm just going to ask the calculator to guess this intercept, and there it is. It pops right there at 1.154. 1.154. Okay? So that should be the same as we got yesterday with method 1, right here. Okay, any questions about what I've done here for method 2? You're finding the same values, just a little bit different way. So this is a different method. Any questions? Which do you like better, method 1 or 2?
1.
Okay, I've heard both, 1 or 2. Okay. Yeah, question?
For the top where it says determine t intercepts.
Yeah.
Are just in like x intercepts?
Those are like x-intercepts, but this is a t in here, so yeah. So if this was x, right, like the variable, then this would be x-intercepts. Because this is actually the t-axis, that's why I said the t-intercepts, but it's the same as the x. You bet. Okay, good. Any other questions? All right. Let me talk about a few more things. There's your assignment, of course. Again, you saw that yesterday. Let me talk about a few more things. Remember for the quiz tomorrow that standard form for an equation, standard form, where did we talk about that? Probably in section 1. Standard form is this right here. Okay, so please remember that. There's no numbers on the left side. There's like a y or some variable on the left side all by itself. And then you have a standard form for quadratic is some number, this could be 1 or a negative or a fraction or whatever, times x squared. So the whole thing that makes it a quadratic, right, is that the largest exponent on the x value is a 2. If it's a 3 or a 4 or a 0.5 or something like that, then it's not a quadratic. The largest has to be a 2, and you can have an x term, you don't have to have an x term. This is what's required, the x squared. Okay? So that's standard form of quadratic. We're going to learn different forms as well. All right, so we talked about intercepts. The axis of symmetry, just a reminder, if you're given intercepts, you can find the axis of symmetry by finding the value that's exactly between those two intercepts, right? And we did this here the other day. But also remember that if you're given any 2 points that have the same y value, so this is like, let's say this is like negative 3.8 and 8, okay? And this is positive 2.8, let's go 2.8, roughly, comma 8. Please notice that because these two have the same y value, that means they're on a horizontal plane, right? They're on the horizontal line. So because your parabola is symmetrical, if you're given 2 points like this that have the exact same y value, that means that the axis of symmetry is exactly halfway between the x values of those points. So it's very similar to the intercepts, except the y value can be any number. It can be 8, could be 10, could be -5, could be 14. So then the axis of symmetry is exactly halfway between the x value of -3.8 and the x value of +2.8. Okay? All right, so the idea of symmetry in a parabola is very, very important. Okay. All right, so I'm going to give you some time now to finish your 7.3 homework. You do have a quiz coming up tomorrow on 7.1 to 7.3. So if you have any questions about your homework, please ask. Work with each other, that's fine. Ask me if you want me to do something on the board. But you're responsible for 7.1 to 7.3. Any questions at this point? All right, go ahead.
That was easy.
Yes, it was.